Hi all, welcome to another video of machine learning. In this video, we can see some terms or concepts related to linear regression. Okay, so the first term we are going to see is what is multivariate regression. So you can see the definition here. Multivariate regression, that is an extension of multiple linear regression. We have studied what is a multiple linear regression, where the dependent variable, that is a function of more than one independent variables, fx2, x3, like that it goes on. So we have multiple, here we have multiple linear regression, we have one dependent variable and many independent variables, but in multivariate regression we have multiple dependent variables, that is we have more than one y variable instead of just one. Okay, so here we can see the difference. Multiple regression, one dependent variable and multiple independent variables. Multivariate regression, multiple dependent variables, y1, y2, y3, etc. and multiple independent variables. So this is what is the concept of multivariate regression. We can see the equation here. So this can be written like this. So the dependent variables and independent variables, the relation, the equation of multivariate regression, it's represented by vectors, arrays. Okay, it's represented as arrays. The variables are represented as arrays or vectors. So y1, y2 are the dependent variables, x1, x2 are the independent variables, and beta, all the betas are the regression coefficients. Okay, so this is actually the equation and definition of multivariate regression. So we can see some examples. We will have more than one output, that is predicting house price as well as the rental price. Earlier we have seen in linear regression predicting house price based on size, location and rooms, that is multivariable linear regression. Multivariate means we can predict house price as well as its rental price based on its area, location and rooms. Then predicting the blood pressure and cholesterol levels. We have two outputs here. Y1 is the blood pressure, y2 is the cholesterol based on age, weight, based on this independent variables. Okay. Then analyzing how the advertisement spent. How can the customer service be improved by making the spending the effects of both revenue and customer engagement. How advertisement spent affects both revenue and customer engagement or customer retention. All these things can be studied together, and that is what is known as multivariate regression. We will have more than one dependent variable. Okay, that is what is known as multivariate regression. Then we can see some applications of regression. We can see here the best example, that is in business and finance. Business and finance, we can see today all the stock trading, all these are AI powered. So the first example is stock market prediction used based on historical data, and sales forecasting of any, for example, supermarket sales, e-commerce, shopping, etc. Everything we can be estimated based on the past performance. That is one important example. Another important example we have in our healthcare. Disease prediction, predicting the risk of disease based on the historical data of the patient. Then drug effectiveness, evaluating the impact of treatments using impact of treatment, how much is the medicine or the drug is effective. That can be the impact of that using, we can model that using the regression models. Okay. The next important one is education and research. We can analyze all the factors that can affect the student performance or scores of students. Then the next one is sports analytics. The performance of players. What are the factors affecting the performance of players? Player performance prediction. Then prediction of equipment, chances of equipment failure, quality control. Another important engineering aspect is the quality control. Then as we have already seen, the house price prediction, all those things come under the application of regression. Okay. So we have just seen a few examples. We have so many, lots and lots of application that comes in the regression. Then next important concepts, that is the bias and variance. Okay, so we can see in detail what is bias and what is variance. Any model will have, there are chances of 3 errors. So the total error in any model, that is the sum of bias error, variance error and irreducible error. Irreducible error means that is actually noise. It's not reliable. We won't be able to predict it. It's external noise. It's not reliable, and we cannot reduce it to much extent. Okay. So we can neglect that error. That is okay. Then we are dealing with bias and variance. What is bias? Bias is actually the error due to overly simplistic assumptions in the learning algorithm. That means the model continuously or consistently underfits the data. That means what is happening here is we are applying only simple decisions are applied on the model. We are applying only simple decisions on the model and not applying any complex decisions. The complex patterns we are not taking into consideration while modeling a function. So there occurs an error that is due to bias, and that is consistently underfitting the data. Consistently underfitting the data means it will have poor performance on both training and test data set. Okay. So that is it's ignoring important pattern. Okay. It's ignoring important pattern. We can see an example here. Predicting a house price based on only on the number of bedrooms. We are just ignoring what in this case we are ignoring the area of the house, location of the house, size of the house, location of the house, number of bathrooms, everything we are ignoring, and we are predicting the house based on some irrelevant information. We can't say it's irrelevant, but only limited data. We are predicting the house only with number of bedrooms or any one or two factors we are taking into consideration that can due to consistently underfitting the model and error occurring due to that. That is known as bias error, and it will have poor performance on both training and test data. So it will have a high bias error because it cannot capture the complexity of the data. How complex? The complexity of the data is not properly captured. Linear regression model we are modeling a linear regression with highly non-linear relationship. That is the scenario here. Linear regression model with highly non-linear data will cause high bias because the complexity is not properly captured. Only simple decisions are applied. Complex decisions are not applied on the data. That is what is known as bias. Then we can see what is variance. Variance is the error due to high sensitivity to training data. That means the model is becoming more complex. So this variance model consistently overfit the data. It memorizes the training data very well. It's very complex. It's overfitting means all the complexities of the data are included. The model is highly complex. So it memorizes all the training data, but it fails when it's generalized on an unseen data. That's it. It performs well on training data, but not on test data. It captures noise. Along with all the actual patterns, the noise is also captured because the training data was too complex. Model is too complex for the given data set. Okay, here is the scenario. We have already seen what is a linear regression, right? We have some other regression, that is high degree polynomial regression, that we can see in detail in the coming sessions. Another regression method that perfects fit on the training data, but on a new data it will have high variance. Okay, if the relation is not properly modeled, it can have a high variance in the new unseen data. So here is an example. A student, that is in this situation we have seen the model is memorizing the training data but fails on unseen data. The same thing. A student is memorizing answers for the practice test, but for real exam the student can fail because the questions are unseen. That's the first time they are seeing the question, so they can fail because they have studied only memorized the answers without understanding the concepts of the practice test. Okay, that is an example of variance. So here is the situation. Low bias and high variance, it can lead to overfitting. High variance can lead to overfitting, and high bias and low variance. High bias and low variance. The first high bias is there will be low variance, and it can lead to underfitting of the data. So what is the solution? Solution is we have many solutions here. Regularization, more data, and feature selection. So what is regularization? Regularization is a technique to prevent overfitting. We have some regularization like L1 regularization, L2 regularization, that is lasso regularization, ridge regularization. All those things are there that we can see. These are all the techniques used to prevent overfitting, or to avoid overfitting we are using this technique. Okay. Then collect more data so that our model is exposed to more and more training data. So it will be more generalized on an unseen data. Okay, it generalizes more well on an unseen data. Then feature selection, choose the features properly. So instead of, in the first example we have seen they have taken only the number of bedrooms, but instead of that choose the features properly. Okay, choose the columns properly so that all the required features are used for training the data. So it will not fail on the test data. Okay. So one more graph we can see regarding the bias and variance. So here you can see the complexity of the model is increasing in this axis. Okay. The complexity of the model is increasing. So as the complexity of the model increases, the bias error decreases. This is the bias error. As the complexity of model increases, the variance error increases. So this is the error. Okay. The total error. The total error is always the sum of these two plus the noise data. So the total error will be always like this. That's the sum of bias error, variance error and noise. So the complexity increases. So here is less complex. This is optimal complex. So always choose for optimal complex data and to try to avoid over complexity as well as less complex data. Okay. That's all regarding the bias and variance. For more ML updates and notes, you can follow my channel. Thank you.